efficiency. We can measure the program, well, if not efficiency, then at least the program speed, how long it takes to run. We can do that by getting the time at the beginning and the end of the operation. Let me put this big prime back in here. 1 and then 8 zeros and 7, 1 billion and 7. And I'll turn this off. And when I run it, it very quickly finds that 1,000,000,007 is prime. It didn't take long at all, but how long did it take? It wasn't zero time. One way we can time our VI is go into the timing functions, and there's a very simple one called tick count. If we look at its context-sensitive help, the tick count function tells you the milliseconds on a timer. This is kind of like a stopwatch that runs in thousandths of a second, and every so often it resets itself. So the idea is when you run this, it sends a number out that's the current time on the clock. So if I did that when the program first starts and do it again when it ends and then subtract the difference, this is the time at the end of the program and this is the time at the beginning of the program, and then send that to an indicator called runtime, maybe in milliseconds, and that should tell me how long the program runs. Problem with it, of course, is this is LabVIEW, so it's data flow programming, so there's nothing that makes it do this first and then the loop and then this last, which is what I need it to do. I need to take the time at the beginning of the program, then run the loop to find if the number is prime, and then get the time at the end of the program and subtract them to see the difference, and that'll be how long it took. It's not that easy a thing to do, this kind of sequencing, because LabVIEW's determined the sequence of operations by the flow of data. There is something called a sequence structure. This is how it works. You draw this box. It looks like a strip of film, and I can add a frame before, and I can add a frame after, and put my timing operations inside those frames. Get rid of the bad wires and wire this up again. What this structure does is it runs everything in this frame and then everything in this frame and then everything in this last frame. So it forces an order of operations that otherwise wouldn't happen. If we run this VI now, here's our runtime. We find it only takes about 10 milliseconds to find that this number is in fact prime. Let's take out this divisor indicator and see if that helps at all. Run it again, and that only takes 3 milliseconds. It runs considerably faster. I mean, the difference between 3 milliseconds and 10 is, 2 blinks of an eye, but still it's actually about 3 times faster. Because we're not updating that indicator every time. That indicator was really only there to help us understand how the program was running and what number we were trying. We don't actually need it in the VI. So this thing is called a sequence structure. There's two kinds. There's this kind that shows you, basically it looks like sort of a short film strip. You can also replace it or change it to a something called a stacked sequence structure. It's kind of more like a case structure a little bit. So it still has all 3 frames. They're all still there. Frame 0, the first thing that happens, which is this initial time. And then the second frame is the loop where the primeness is tested and found. And then the last frame is the closing time, the end time. This stacked sequence is a little more efficient, takes up less screen space. It still does the same thing. It's just that you can only see 1 frame at a time, but either of them works. We have some documentation in here in the form of these labels on the wires that give us some clue and some hint of what's going on in the program, and in fact just the names, the labels of these controls also tend to help us. They kind of count as documentation because they help us understand what the program is doing and how it works. we're using a while loop with a shift register, and the shift register contains the integer that's the divisor, the number that we're trying to divide the number by to see if it divides evenly. And that's basically it. Now, I guess the last thing we should do is, this is a fairly handy little function, so we should wire it up. A place for the number and a place for the Boolean, and I've already edited the icon up here. The runtime, I can leave it in the program, it doesn't really do any harm. I don't really need to send it to an output, so even though it's an indicator on the front panel, I really don't need to wire it up. I don't really ever need to send this runtime out of the subVI, so I can pretty much leave it the way it is. Okay, so that's for testing whether a number is prime or composite, which means basically a number that isn't prime. All right, I hope that helps.